What if something sitting on your kitchen table right now, something you've consumed hundreds, maybe thousands of times without a second thought, could be quietly influencing one of the most feared diseases of our time? Not in an immediate or obvious way, but gradually, invisibly, shaping the internal environment of your body in ways that scientists are only beginning to fully understand. This is not a claim designed to shock without substance. It is a question grounded in decades of evolving research into how diet interacts with human biology at the most fundamental level. Cancer, at its core, is not a foreign invader. It begins within the body itself, when normal cells lose the ability to regulate their growth. These cells divide uncontrollably, evade natural death mechanisms, and eventually form tumors that can spread.
But this transformation doesn't happen in isolation. It occurs within a biological environment, one that is heavily influenced by lifestyle, genetics, and crucially, diet. Among the many dietary factors under investigation, one stands out for both its ubiquity and controversy: sugar. Refined sugar, added sugars, and high glycemic carbohydrates have become deeply embedded in modern diets. From soft drinks and desserts to bread, sauces, and even so-called health foods, sugar is everywhere. And while it has long been associated with conditions like diabetes and obesity, its potential role in cancer biology has drawn increasing attention. To understand why, it's important to first look at how cells generate energy. Every cell in the human body relies on glucose, a simple sugar, as a primary fuel source. Under normal conditions, cells use oxygen to efficiently convert glucose into energy through a process called oxidative phosphorylation. However, cancer cells behave differently. They often rely on a less efficient process known as glycolysis, even when oxygen is available. This phenomenon, first described by German scientist Otto Warburg in the 1920s, is now known as the Warburg Effect. The significance of this lies in the fact that glycolysis requires far more glucose than oxidative phosphorylation to produce the same amount of energy. In other words, cancer cells are voracious consumers of glucose. They absorb it rapidly and in large quantities, fueling their rapid growth and division. This doesn't mean sugar directly causes cancer, but it does raise an important question. If cancer cells depend heavily on glucose, what happens in a body where glucose is consistently abundant? Modern dietary patterns provide a partial answer. In many parts of the world, particularly in urban and industrialized societies, sugar consumption has reached unprecedented levels. Sugary beverages alone account for a significant portion of daily caloric intake for millions of people. Add to that processed snacks, baked goods, and hidden sugars in packaged foods, and the cumulative intake becomes substantial. When large amounts of sugar are consumed, the body responds by releasing insulin, a hormone that helps cells absorb glucose from the bloodstream. Frequent spikes in blood sugar lead to repeated insulin surges. Over time, this can result in insulin resistance, a condition in which cells become less responsive to insulin's effects. The body compensates by producing even more insulin, leading to chronically elevated levels. This matters because insulin is not just a metabolic hormone, it is also a growth signal. High levels of insulin and related molecules, such as insulin-like growth factor 1, can promote cell proliferation and inhibit apoptosis, the process by which damaged or abnormal cells are programmed to die. In a healthy system, apoptosis serves as a safeguard against cancer. When this process is disrupted, the risk of abnormal cell survival increases. At the same time, high sugar intake is strongly linked to obesity, another major risk factor for cancer. Fat tissue is not merely a passive storage site for energy, it is metabolically active, producing hormones and inflammatory substances that can influence cell behavior. Excess body fat can lead to increased levels of estrogen, particularly in postmenopausal women, which is associated with higher risks of breast and endometrial cancers. Inflammation is another critical piece of the puzzle. Chronic low-grade inflammation is increasingly recognized as a driver of cancer development. Diets high in sugar and processed foods can trigger inflammatory responses in the body, leading to the release of cytokines and other signaling molecules that can damage DNA and promote tumor growth. But the relationship between sugar and cancer is not straightforward. It is shaped by a complex interplay of factors, including overall diet, physical activity, genetic predisposition, and environmental exposures. This complexity has led to some confusion and debate within the scientific community. Some studies suggest that high sugar intake is associated with increased cancer risk, particularly for certain types such as colorectal and pancreatic cancers. Others find weaker or more indirect links. What is becoming increasingly clear, however, is that sugar's impact is often mediated through broader metabolic effects rather than direct causation. Refined carbohydrates add another layer to this issue. Foods like white bread, pasta, and pastries are rapidly broken down into glucose, causing similar spikes in blood sugar and insulin. From the body's perspective, these foods can behave much like sugar itself. This means that even diets that appear low in added sugars may still contribute to high glycemic loads. The concept of glycemic index and glycemic load has become important in understanding these dynamics. High glycemic foods cause rapid increases in blood sugar, while low glycemic foods result in slower, more gradual rises. Diets dominated by high glycemic foods are associated with increased risks of metabolic disorders and, potentially, certain cancers. Beyond metabolism, there is growing interest in how sugar affects the gut microbiome. The human gut is home to trillions of microorganisms that play essential roles in digestion, immunity, and overall health. Diets high in sugar and low in fiber can disrupt this microbial balance, leading to dysbiosis, a state associated with inflammation and disease. Some research suggests that certain gut bacteria can influence how the body responds to cancer therapies, including immunotherapy. This raises the possibility that diet, by shaping the microbiome, could indirectly affect cancer outcomes. Globally, these findings carry significant implications. As countries undergo economic development and adopt more westernized diets, rates of obesity, diabetes, and cancer are rising. This trend is particularly evident in regions where traditional diets, often rich in whole grains, vegetables, and legumes, are being replaced by processed foods high in sugar and fat. Public health experts are increasingly concerned about this shift. The World Health Organization and other bodies have issued guidelines recommending limits on added sugar intake, typically no more than 10% of total daily calories, with further reductions to 5% offering additional health benefits. Despite these recommendations, average consumption in many countries remains well above these levels. Policy responses have varied. Some governments have implemented sugar taxes on beverages, aiming to reduce consumption and generate revenue for health initiatives. Others have introduced clearer food labeling requirements, making it easier for consumers to identify added sugars. Early evidence suggests these measures can lead to modest reductions in sugar intake, though long-term impacts are still being evaluated. The food industry, meanwhile, faces increasing pressure to reformulate products and reduce sugar content. However, sugar plays multiple roles in food beyond sweetness, including texture, preservation, and flavor enhancement. This makes reformulation challenging and sometimes controversial. For individuals, navigating this landscape can be difficult. Conflicting information, marketing claims, and deeply ingrained habits all contribute to confusion. Yet the core message from most experts is relatively consistent. Focus on overall dietary patterns rather than single ingredients. Whole foods, vegetables, fruits, whole grains, nuts, seeds, and lean proteins provide a range of nutrients that support cellular health. These foods are typically lower in added sugars and higher in fiber, which helps regulate blood sugar levels and supports a healthy microbiome. Fiber, in particular, deserves attention. It slows the absorption of glucose, preventing rapid spikes in blood sugar. It also feeds beneficial gut bacteria, which produce short-chain fatty acids that have anti-inflammatory properties. Diets high in fiber are consistently associated with lower risks of colorectal cancer. Physical activity complements these dietary strategies. Regular exercise improves insulin sensitivity, reduces inflammation, and helps maintain a healthy weight. It is one of the most effective lifestyle interventions for reducing cancer risk. Alcohol consumption is another factor that interacts with diet. Excessive alcohol intake is a known risk factor for several types of cancer, and alcoholic beverages often contain significant amounts of sugar. Reducing alcohol consumption can therefore have multiple health benefits. It's also important to recognize that not all sugars are created equal. Natural sugars found in whole fruits come packaged with fiber, vitamins, and antioxidants. These components slow sugar absorption and provide protective effects. In contrast, added sugars in processed foods offer little nutritional value and are often consumed in excess. Reading food labels can help identify hidden sources of sugar. Ingredients lists may include various forms of sugar under different names, such as sucrose, glucose, fructose, corn syrup, and others. Becoming familiar with these terms can empower consumers to make more informed choices. At the clinical level, researchers are exploring how dietary interventions might support cancer treatment. Some studies are investigating whether reducing sugar intake or adopting low glycemic diets could slow tumor growth or improve treatment outcomes. Others are examining ketogenic diets, which drastically reduce carbohydrate intake, as a way to limit glucose availability to cancer cells. However, these approaches remain experimental and are not universally recommended. Medical professionals caution against oversimplifying the relationship between sugar and cancer. Eliminating sugar entirely is neither practical nor necessary for most people. The goal is balance, reducing excess intake while maintaining a nutritious and sustainable diet. The psychological aspect of dietary change should not be overlooked. Food is deeply tied to culture, emotion, and social interaction. Effective public health strategies must consider these factors, promoting changes that are realistic and culturally appropriate. Education plays a key role. Increasing awareness about how diet affects health can empower individuals and communities to make better choices. Schools, workplaces, and healthcare providers all have roles to play in this effort. As the science continues to evolve, one thing becomes increasingly evident. The relationship between diet and cancer is complex, but it is also actionable. While no single food determines health outcomes, patterns of consumption over time can significantly influence risk. The idea that a common food could feed cancer cells is not meant to alarm but to inform. It highlights the importance of understanding how everyday choices can shape biological processes. It underscores the need for a more thoughtful approach to diet, one that prioritizes long-term health over short-term convenience. In a world where processed foods are often cheaper and more accessible than healthier alternatives, addressing these issues requires coordinated efforts at multiple levels, from individual behavior to industry practices to government policy. Yet, even within this complexity, there is a clear and empowering message. Small changes made consistently can have a profound impact. Reducing sugary drinks, choosing whole foods, increasing physical activity, these are not radical steps, but they are powerful ones. They represent a shift from passive consumption to active decision-making, from reacting to disease to proactively supporting health, from uncertainty to informed choice. And in that shift lies the potential not just to reduce cancer risk, but to improve overall well-being in a way that extends far beyond any single disease.